All right, so we've already talked about differentiating if we have base e. For example, can you differentiate e to the x? Sure, it's just e to the x. Can you differentiate e to the 2x? Well, we have to use a little bit of the chain rule, but yeah, we can do it. We just get 2 times e to the 2x. What about if we have an exponential function and my base isn't e? Say 2 to the x, or 7 to the x, or 1/2 to the x. Well, it's pretty basic as long as you can get the formula down, because once you get the formula down, it's just following the formula. And so the derivative, remember this stands for the derivative, so the derivative with respect to x of a raised to some u is just ln of a times a to the u, so notice this is reappearing, times the derivative of u with respect to x. So I'm giving you the formula for the fact that whatever it's being raised to is its own function. If it is just being raised to an x, you can lose this du dx part. So now that I've given you the formula, I want to go through 4 examples where we look at how that formula gets used. So let's say on number 1, I have y equals 5 to the x. Well, I notice it's in the form a to the u, where my a is 5. I don't really need to call it a u since it's just an x, but just to go through the process I will. My u is x. My du dx, which is the same thing as u prime, is just 1. Following my formula, y prime, the derivative of 5x, becomes ln of 5 times a to the u, which is just 5 to the x, times du dx, which we said was just 1. There's really no point to multiplying things by 1. So here is my final answer. Here's my derivative. It is important that you put the parentheses around ln of 5 or that you put the 5x out front so it doesn't look confusing about what you're taking the natural log of. If I look at my next example, y equals 4 to the 3x, doing the same thing. My a is 4, my u is 3x, and my du dx, or my u prime, is just 3. Following my formula, the derivative of 4 to the 3x, y prime, is ln of 4 times 4 to the 3x times 3. One thing you want to be careful of is that these cannot be multiplied because this has this exponent, this one does not. So we would be disobeying our order of operations if we multiplied before we did the exponents. I can, however, take this 3 and put it out front because the order that I write things in, if it's all multiplication, doesn't matter. The reason I want to point that out is because you will do some example problems from the book, and I do not know which form the book is going to ask you to put your answer in or what the back of the book is going to look like. So I want to point out that this is the same thing as this because it doesn't matter if I multiply at the end or multiply in the beginning. And remember, we have that rule that tells us if we multiply on the outside of a logarithm, I can bring it up and make it an exponent. So this is the same thing as saying ln of 4 cubed times 4 to the 3x. So I also could do 4 cubed. So just some FYI, because like I said, I don't know exactly what form the book is going to put it in. Looking at the last 2 examples for this video, I have f of x equals 3 to the x over 2. I notice it is exponential. Once again, my a is just my base, which is 3. My u is x over 2. Remember, that's the same thing as saying 1/2 times x. My u prime then is just 1/2. So I get f prime of x equals ln of a times a to the u. Oops, I'm going to write an a. I meant to write 3 to the x over 2 times my u prime, which is 1/2. So I can either write it like that, or if I want to, I can bring the 1/2 out front and have 1/2 ln of 3 times 3 to the x over 2, or if I wanted to, I could bring the 1/2 up on the 3, or I could rewrite it as the square root of 3, so a couple different options. I'm kind of out of room here, so I'm just going to stop there, but know that you could take those other options. And then looking at my final example for this video, again, I notice that I have an exponential function here, g of x equals 1/2 raised to the 2 over x squared function. I can't square it if it's already in an exponent, which is why I have the caret. So I'm going to let my a be my base, which is 1/2. Now I'm going to let u be 2 over x squared. Because I know I'm going to have to differentiate this, I'm going to write it as 2x to the negative 2. And then my u prime, if I can squeeze it in here, would be negative 4x to the negative 1. I think I got it in there. So then differentiating g of x, I get g prime of x equals ln of a times a to the u, either 2x to the negative 2 or back 2 over x squared, times u, which is 4 times x to the negative 1, which is the same thing as 4 over x if I make that positive. So here's my final answer. Again, not a whole lot I can do to make it look nicer. I could put the 4x out front if I wanted to, ln of 1/2 times 1/2 over 2 over x squared. I'm not sure that really looks any better though. I could take the 4 over x up and make it an exponent on the 1/2. So again, just some options I could do in terms of the way I want to write it. But that's all I need to do to differentiate a exponential function whose base is not e. So get the formula down, because once you have the formula down, this is just some basic differentiating tools that we've used before.